Hello students, myself Deepali Jain and I am working as an assistant professor in Department of Pharmaceutical Chemistry at Kekewa College of Pharmacy, Nashik. Today we perform the practical on determination of physicochemical properties of the drugs course content using free online services. So firstly we see the introduction. Bringing a pharmaceutical drug to the market is a long process that costs 65,000 crore of Indian rupees. One promising approach for improving the efficiency and productivity of early discovery in the pharmaceutical industry and academia is virtual screening that uses computer-based methods. The ultimate final goal of virtual screening is to identify drug-like molecules with the best chance to become an effective medicine. It has been demonstrated that early estimation of QADME and toxicology ADMET, that is absorption, distribution, metabolism, excretion and toxicology, these parameters in the discovery phase reduces drastically the fraction of pharmacokinetics related failure in the clinical phases. So according to Lipinski's rule, or it is also known as rule of 5, it states that in general an orally acting drug has no more than one violation of the following criteria, such as first one is hydrogen bond donor, that is NH and OH bonds not more than 5. Second one is hydrogen bond acceptors, that is all nitrogen and hydrogen atoms not more than 10. Then third one is molecular mass less than 500 daltons, and fourth criteria is an octanol water partition coefficient log 5 not greater than 5. These are the criteria for Lipinski's rule. Nonetheless, drug-like molecule predicted by Lipinski's rule has spawned many extensions including Gauss rule, lead likeness and bioavailability rules. Accurate prediction of log P is highly important for the pharmaceutical industry since it limits costly and time-consuming experiments to measure the log P, which is required to optimize pharmacodynamics and pharmacokinetic properties. So for that, N log P, A log P, consensus log P and A log P 98, these are the best method for online log P prediction. So there is some online services for the determination of physicochemical properties. We can see step by step. So first one is Swiss ADME. By using this link or by using this site, we can use this online service for the determination of physicochemical properties which include lipophilicity, water solubility, pharmacokinetics, drug likeness and medicinal chemistry. Second one is Mol Inspiration. By using this site, this is the free online service for the calculation of important molecular properties and bioactivity score for the most important drug target. Next one is Series Property Explorer. We can use this site or this link, which is free online services for the toxicity risk assessment, physicochemical properties and drug likeness. And next one is PKCSM. So for that, by using this site or this link, we can predict the pharmacokinetics and toxicity properties. So now we can see step by step how these online services we can be used. So first one is Swiss ADME. By copying or by using this link on Google Chrome, this page is open. Okay. After that, when we and for second, that is Mol Inspiration, by using this link, this page is open. So we will see step by step. First one is by using Swiss ADME. Our example is Paracetamol. For that, when we go for on Google Chrome and search for Swiss ADME, this page is open. After that, when we draw our drug molecule structure, after that this red button or red click is available. By clicking this red click, we form here smiles, and smiles means simplified molecular input light entry system. For example, see here, when we draw the structure of paracetamol, click on red button, the smile is formed. Okay, this smile, after forming this smile, we can click on run. Then this is open for paracetamol, that is physicochemical properties of paracetamol, which include structure and 3D structure of paracetamol. After that there is the smiles, then physicochemical properties, lipophilicity, water solubility, pharmacokinetics, drug likeness, and medicinal chemistry. Now we can see step by step what is it include. So first one is structure. So this is basic structure of paracetamol, and this is 3D structure of paracetamol, and at below there is the smiles which can form by this online service. It includes physicochemical properties such as molecular formula contain C8H9NO2, and molecular weight of paracetamol is 151.16 gram per mole. Number of heavy atoms are 11. Number of aromatic heavy atoms are 6. Then fraction CsP3 is 0.12. Then number of rotatable bonds are 2. Number of hydrogen bond acceptors are 2. Number of hydrogen bond donors are 2. Molar refractivity, that is 42.78, and TPSA, that is 49.33. These are the physicochemical properties generated by using this free online service. After that, it also includes lipophilicity of paracetamol, that is log P in octanol and water partition coefficient. So it includes I log P, that is its value is 1.21, X log P3, which predict the log P value of a Curie compound by using the known log P value of a reference compound at the starting point, and its value is 0.46. After that, W log P, its value is 1.16. Then N log P, its value is 0.9191. Then silicose IT, its value is 0.89, and consens log P, its value is 0.93. Here, silicose IT means which a hybrid method relying on 27 fragments and 7 topological descriptors. This is the lipophilicity for paracetamol. Next one is water solubility, where log S, that is ESOL, which is from estimating the aqueous solubility directly obtained from molecular structure. So log S is minus 1.34. Then solubility class is very soluble in water. Next one is log S ALI. It means determines the log in silico prediction of aqueous solubility incorporating the effect of topological polar surface area. So its value is minus 1.06, and solubility class is very soluble. After that, log S value of silicose IT. Silicose IT means a hybrid method relying on 27 fragments and 7 topological descriptors. Its value is minus 2.19, and solubility class is soluble in water. These are the water solubility of paracetamol. After that, pharmacokinetics, in which GI absorption is high, BBB permeant means blood-brain barrier, yes, then P group substrate, no, CYP1A2 inhibitor, that is cytochrome P450 inhibitor, no. Next, CYP2C19 inhibitor, these are the types of cytochrome P450 inhibitor, and these are the present or absent, so there is no. And last one is log Kp, that is skin permeation, its value is minus 6.90 centimeter per second. These are the pharmacokinetic property of paracetamol, which is also determined by using Swiss ADME online service. After that, there is drug likeness. So by using different rules, drug likeness can be obtained or determined. For this, first one is Lipinski's rule. Yes, this is drug likeness because there is zero violation. After that, Gauss rule, no, because one violation, that is molecular weight 160. Then after that, Weber rule, yes, it produces drug likeness. Then Egan, yes, it is also produces drug likeness. Then Hughes, no, because of one violation, that is molecular weight of 200. And then bioavailability score is 0.55. These are the drug likeness of paracetamol. After that, medicinal chemistry, which include pains, that is 0 alert, then brain 1 alert of hydroquinone, then lead likeness, no, because one violation is present, that is molecular weight of 250, and synthetic accessibility, that is 1. These are the medicinal chemistry property of paracetamol. After that, we can see by using mole inspiration, we can calculate or we can determine the physicochemical property of drug molecule. Okay, so here we can see example related to benzene and paracetamol. How we can use this mole inspiration online service. So for example, here we can see benzene. By using the mole inspiration online service, after searching on Google Chrome, this site is open. After that, we can draw the structure of benzene and click on predict property. Then this site is open, in which mole inspiration property produces molecular weight, that is 78.11 gram for benzene, volume is 84. After that, if we click on predict bioactivity, then this page is open, which include mole inspiration bioactivity score, that is GPCR ligand, ion channel modulator, kinase inhibitor, nuclear receptor ligand, protease inhibitor, and enzyme inhibitor. If we can go for further physicochemical property determination, then we can click on Get 3D Geometry. After that, this page is open, which includes the 3D structure of benzene. This is the CPK type of structure for benzene. After that, if we click on dotted, then this structure is open. If we click on tube, then this structure is open, and if we can click on wires, then this structure is open. So by using this mole inspiration online method, we can determine the different physicochemical properties of drug molecule. Now we can see the second example, that is paracetamol, by using mole inspiration online service. So same as that of benzene, after drawing the structure of paracetamol, and we can click here for calculate properties, predict bioactivity, and galaxy 3D generator. After drawing the structure of paracetamol, there is the non-inspiration property arrived, such as molecular weight, MOM, then volume. After clicking on predict bioactivity, we can got this bioactivity score, that is GPCR ligand, then ion channel modulator, then kinase inhibitor, nuclear receptor ligand, then protease inhibitor and enzyme inhibitor. After clicking on this 3D geometry, we can form the 3D structure of paracetamol. So this is the CPK type of structure for paracetamol. After that, if we click on dotted, then we got the dotted structure of paracetamol. After we clicking on tubes, this is the tube type structure of paracetamol. And if we click on wires, then this is the structure of wire type of wires of paracetamol. So this is used of non-inspiration free online service for the determination of physicochemical properties. Now we can see step by step how this online service can be used. Now we can see how we operate this online free services. Okay, so first one is Swiss ADME. After clicking on this link or by using this link, we open on Google Chrome. After that, this page is open. Okay, now we can click on this import and here we can type our drug name, or if we can use the structure such as benzene. Okay, this structure is formed. After that, we click on this red sign button and click on run. Then this smile is obtained, and below this side the physicochemical properties of benzene are obtained. You can see here there is a structure of benzene. This is 3D structure of benzene. Then physicochemical properties of benzene, which include formula, molecular weight, number of heavy atoms, number of aromatic heavy atoms, fraction, then number of rotatable bonds, number of hydrogen bond acceptors, number of hydrogen bond donors, molar refractivity and PSA. Then after that there is the lipophilicity. Then you can see here water solubility, pharmacokinetics, drug likeness and medicinal chemistry of benzene. So we can use this side as the determination of physicochemical property. And after using this side, we can calculate the physicochemical property. Okay. Next one is, if we use after using this mole inspiration, we add how this mole inspiration we use by clicking on this side or by using this link. This page is open, that is mole inspiration. Now we can enter here. If we can use this smile of benzene, if we copy this smile and paste on mole inspiration, then now we can calculate the property. Okay, so this is the structure of benzene. You can see there is formation of mole inspiration properties, which include molecular weight, that is 78.94, amyl of P, that is 1.94, then N violations 0, N rotable 0 and volume 84.04. After that, if we click on predict bioactivity, this next site is open which contains mole inspiration bioactivity score, in which GPCR ligand, that is -3.66, then ion channel modulator, kinase inhibitor, nuclear receptor ligand, and protease inhibitor and enzyme inhibitor. These are the value or bioactivity score for benzene. After that, if we click on get 3D geometry, then you see here the formation of 3D structure of benzene. This is the CPK type. After clicking on dotted, this is the dotted type of benzene. After clicking on tubes, this is the tube type of benzene, and this is the bio type of benzene. So these are the different types of structure of benzene by using mole inspiration online service. Okay. Now third one is Osiris Property Explorer. For that, if we find this property on Google Chrome by typing the Property Explorer or Osiris Property Explorer, this site is open. For example, if we draw the structure of benzene here, now you can see here the structure of benzene, and there is the properties, that is Osiris Property Explorer contain predicted toxicity risk. This is mutagenic, tumorigenic, then irritant and reproductive effective, and other predictive properties such as C-log-P, solubility, then molecular weight, that is 78.11, then drug likeness, then hydrogen bond acceptor, hydrogen bond donor, NB stereocenter, NB rotatable bond, and drug score, that is 0.06. So by using this Osiris Property Explorer, we can also find out the toxicity risk assessment. Okay, these are the online services which are free for the determination of physicochemical property. Now students, let us see the another example by using Osiris Property Explorer. Okay, for example, we can see para-aminophenol or 4-aminophenol. By drawing the structure, firstly we use benzene ring here, then single bond, then we attach OH group here, again we take on single bond, and here is the example of para-aminophenol, so we attach amino group to this single bond. Okay. Next, if after we drawing the structure of para-aminophenol, here you can see the predicted toxicity risk is occur. For example, there is some toxicity property, and here is the green signal to the tumorigenic property. Okay. Next one is predicted properties, which include C-log-P, then solubility, molecular weight. The molecular weight of this para-aminophenol is 109.13 gram. Then drug likeness is -1.22, hydrogen bond acceptor R2, then hydrogen bond donor R2, and drug score is 0.13. So this is the Osiris Property Explorer online service. Okay. Now we can see how PKCSM online service can use for the determination of physicochemical property. For that, we can go to the Google Chrome by typing or by linking this site. After that, this page is open. You can see here two options are obtained, that is PKCSM and license. After that, you click on PKCSL. This page is open. Now we can use the smiles here. For example, if we can use smiles of paracetamol, now we can use this smiles. We copy and paste on this side. Okay. After that, rolling down, there is the prediction of pharmacokinetic properties. By clicking the absorption property here, the pharmacokinetic properties are obtained. The page is open. Now you can see here the molecular depiction of paracetamol and absorption property here. So molecular weight of paracetamol is 151.165 gram per mole. Then log P is 1.3506. Rotable bonds are 1, and here hydrogen bond acceptors present are 2 and donors are 2. Then the surface area for this drug molecule is 64.667, and main are the properties. Here we can see absorption property for paracetamol. So water solubility predicted value is minus 1.485. Then you can see the number of properties are obtained and their predicted value. By clicking on the back, then clicking on distribution, here the distribution property of paracetamol is obtained. Okay. So same molecule properties such as molecular weight, log P, rotable bonds, acceptors and donors, and surface area of paracetamol, and the property name is distribution, where predicted value for VDSS in human, then fraction unbound. BBB permeability means blood-brain barrier permeability minus 0.234, and CNS permeability is minus 2.851. This is the distribution property of paracetamol. Then again we click on back button. For next one is metabolism property. Then these are the metabolism property of paracetamol. Here you can see CYPD-D6 means cytochrome PD6 substrate, no. Then these are the subtypes of cytochrome P4 cytochrome proper enzyme. Okay. Again we click on back. Next one is excretion of the paracetamol. These are the excretion property of paracetamol, in which total clearance is running and its unit is log milliliter per minute per kg, and renal substrate is categorical, that is yes or no, that is predicted value is no. Okay. Next property is toxicity. So we can also determine the toxicity property of paracetamol. So these are the toxicity risk or assessment for the paracetamol. First one is AES toxicity, then maximum tolerated dose in human. Okay, these are the number of toxicity risks of paracetamol. After clicking on back, so ADMET means absorption, distribution, metabolism, excretion and toxicity are calculated in one page. Okay, so here the absorption, distribution, metabolism, excretion and toxicity properties on one page. You can see here. So these are the pharmacokinetic properties of paracetamol by using PKCSL online service. Students, let us see the question bank related to this practical, which is used for some synopsis and viva voce questions. Okay. So first question is, explain Lipinski's rule. Its answer is, Lipinski's rule, that is rule of 5, states that in general an orally acting drug has no more than one violation of the following criteria. And criteria are, first one is hydrogen bond donor not more than 5, hydrogen bond acceptor not more than 10, molecular mass less than 500 Dalton, and optimal water partition coefficient log P not greater than 5. Next question is, enlist the online software or services used for determination of physicochemical properties of drug molecules. And answer is, the online software or services are, first one is Swiss ADME, second one is Mol Inspiration, third one is Oscitis Property Explorer, and last one is PKCSL. These are the online software services. Third question is, what do you mean by SMILES, or what is the full form of SMILES? The answer is Simplified Molecular Input Line Entry System. This is the full form of SMILES. Okay. Next question is, name the common solvent system used in the determination of partition coefficient. So answer is octanol water solvent system. Next question is, enlist the different physicochemical properties which is determined by using online free services. And its answer is, the physicochemical properties are molecular weight, solubility, ADME, that is absorption, distribution, metabolism, excretion, then toxicity determination, molecular formula, drug likeness, and bonds determination, that is hydrogen acceptors or hydrogen donors. Next question is, how much molecular mass of molecule is required as per Lipinski's rule? So its answer is less than 500 Daltons. Next question is, how many hydrogen bond acceptors should be present in molecule as per Lipinski's rule? And answer is not more than 10. Next question is, how many hydrogen bond donors should be present in molecule as per Lipinski's rule? And answer is not more than 5. These are the questions related to this practice.